The subtropical jet stream is already showing a textbook El Niño signature this July, strengthening and shifting exactly the way it normally does during a strong event. The problem is the timing. That specific signature almost always shows up in winter, when El Niño events typically peak, not in the middle of summer. Climate scientists are now watching a developing super El Niño push its atmospheric fingerprint onto the jet stream months ahead of the usual schedule, and the ocean heat driving it hasn't been matched since 1877. Some European climatological centers have already placed the odds of this event reaching full super El Niño intensity by November at essentially certain, a level of confidence rarely reached early in the year. Stick around, because comparing this July's jet stream behavior against a typical El Niño year reveals exactly why forecasters are treating the timing itself as the real story. And let's start with what a normal strong El Niño year actually looks like, since that's the baseline this comparison depends on. During El Niño, warmer than average water spreads across the central and eastern tropical Pacific, and that extra ocean heat releases energy into the atmosphere above it. That added heat strengthens the subtropical jet stream, the branch of fast upper-level wind typically found near the US-Mexico border, pushing it further east and making it noticeably more active. In a typical event, this process builds gradually through the second half of the year and reaches its clearest, strongest signal in winter, which is why El Niño's most famous impacts, wetter winters across the southern U.S. and a quieter hurricane season, are almost always associated with the cold months rather than summer. This seasonal lag isn't arbitrary. It reflects how long it actually takes for ocean heat to fully couple with the atmosphere above it. Warm water alone doesn't immediately reorganize global wind patterns, since the ocean and atmosphere need time to exchange enough energy for the atmospheric circulation to visibly respond. That lag is part of why forecasters have historically waited until autumn or early winter before issuing confident statements about how strongly a given El Niño will actually influence the jet stream and downstream weather patterns. Now here's where this year actually matches that normal pattern, and it's worth being fair about the similarities before getting to what's different. The underlying mechanism driving this year's event is identical to every past El Niño on record. Scientists first detected a subsurface Kelvin wave, a massive underground pulse of warm water moving east across the Pacific toward South America, back in March. That's the same early warning signal that has preceded every major El Niño. Event scientists have tracked, and it behaved exactly as expected, triggering the same chain reaction of ocean warming and atmospheric response that defines the phenomenon. The subtropical jet strengthening near California and across the southern tier of the U.S. is also happening for the same physical reason it always does, through enhanced warming in the upper atmosphere over the tropics releasing latent heat that widens the temperature gradient the jet depends on. Even the sequence of forecast confidence followed a familiar arc at first. Early estimates in March placed the odds of a super El Niño at only around 22%, a fairly typical level of uncertainty for a signal still in its early stages. Climate scientists tracking the tropical Pacific through the following weeks watched the Kelvin wave continue surfacing largely as textbook cases have shown before, reinforcing the sense that this event, while clearly significant, was still following a recognizable playbook rather than doing something entirely unprecedented at the mechanism level. Here's where the comparison starts to diverge in a way that matters. In a typical El Niño year, this level of subtropical jet strengthening simply doesn't show up by July. It's a winter season signature, appearing once the ocean-atmosphere coupling has had months to fully develop. This year, meteorologists tracking the pattern have explicitly noted that the atmosphere is already displaying a clear, recognizable El Niño-like configuration during the first half of meteorological summer, months earlier than forecasters would typically expect to see it emerge with this level of clarity. The speed of that transition is the first major difference worth understanding. Odds of a super El Niño, the strongest classification of the event, jumped from around 22% in March to roughly 80% within about a month, with some European climatological centers eventually placing the odds at essentially certain for a super El Niño developing by November. That kind of rapid escalation in confidence, from a minority possibility to near certainty within weeks, is itself unusual compared to how these forecasts typically evolve since El Niño. Strength projections normally firm up gradually over many months, rather than shifting this dramatically in such a short window. The second major difference is the sheer magnitude of the ocean heat behind it. Sea surface temperatures in the key equatorial monitoring region are running roughly 3 degrees Celsius above average, a level of heat in the Pacific that hasn't been recorded since 1877, according to climate scientists tracking the event. That's not simply a strong El Niño by recent standards. It's a potential outlier even against the full length of the historical record, which stretches back nearly a century and a half. When the underlying heat driving an event is this far outside historical norms, it makes sense that the atmospheric response would also show up earlier and more forcefully than usual. The third difference lies in how forecasters themselves are talking about this event compared to past ones. The National Weather Service's own Climate Prediction Center has explicitly noted that the strongest El Niño events on record are defined by significant ocean-atmosphere coupling extending through the summer months, and stated plainly that it remains to be seen whether that level of coupling will actually occur this year. That's a meaningfully different tone than the confident seasonal outlooks typically issued for weaker or more conventional events, and it reflects genuine uncertainty about how an event this large and this early actually behaves once it fully matures. Forecasters have also been careful to note that dramatic headlines and social media posts can exaggerate the certainty of outcomes, even as the underlying data itself continues pointing towards something genuinely unusual taking shape in the tropical Pacific. Here's the genuinely speculative layer worth flagging clearly. A study published in December 2025 found that Super El Niño events can trigger sudden shifts in regional temperature and precipitation patterns, described by researchers as climate regime shifts, and raise the possibility that this effect could become more pronounced in an already warming world. This remains an active area of research rather than settled science, and connecting this specific July's early jet stream signature directly to that broader climate regime shift hypothesis would be reaching beyond what current data can actually confirm. I'm including it here because it's part of the scientific conversation happening around this event, not because it's been established as fact. If comparisons like this, showing exactly how an unfolding event lines up against the historical playbook and where it breaks from it, are useful to you, like and subscribe, because this channel tracks stories exactly like this one as they develop. So what does this early timing actually imply for risk going forward? If the subtropical jet is already behaving like a mature winter El Niño pattern in the middle of summer, forecasters increasingly expect several of El Niño's classic seasonal impacts to arrive earlier and potentially last longer than usual. That includes a quieter Atlantic hurricane season than might otherwise be expected, since a strengthened subtropical jet tends to increase wind shear across the Caribbean and tropical Atlantic, a condition that generally suppresses tropical cyclone development. It also points toward an earlier and more active pattern of rainfall across the southern tier of the U.S., and a corresponding tendency toward drier, warmer conditions settling into the Pacific Northwest and parts of the northern U.S. and Canada. None of this locks in a guaranteed outcome for the rest of the year. Stronger El Niño events increase the likelihood of certain impacts without ensuring any of them play out exactly as the historical average suggests, which is exactly the kind of caveat the Climate Prediction Center itself has emphasized. What the early timing does suggest is that whatever pattern eventually solidifies this winter may already be partially visible right now, months ahead of when forecasters would normally expect to have that level of confidence. This early visibility cuts both ways for anyone trying to plan around it. On one hand, having a clearer seasonal signal months earlier than usual gives farmers, water managers, and emergency planners a genuine head start compared to a typical year. On the other hand, an event running this far ahead of its usual schedule also means less historical precedent exists for exactly how it behaves from here, since most past Super El Niño events didn't display this level of atmospheric maturity until much later in the year. So what's actually useful for you to do with this information today? If you're in a region historically sensitive to El Niño's summer and fall impacts, particularly the southern U.S., the Gulf Coast, and California, start paying attention to seasonal outlooks now, rather than waiting for the traditional autumn El Niño briefings, since this year's pattern appears to be running ahead of the usual calendar. Farmers and agricultural planners in regions typically affected by El Niño-driven rainfall shifts should treat current seasonal forecasts as more actionable earlier than usual, given how far ahead of schedule this signal has already emerged. If you live in a hurricane-prone area, don't let an expected quieter season lead to complacency, since even suppressed El Niño hurricane seasons have produced significant, damaging storms in the past, and a single system finding its way through unfavorable conditions remains entirely possible. Keep your hurricane preparedness plan current regardless of what the seasonal outlook suggests, since forecast confidence about overall activity levels says very little about any single storm's specific track or intensity. Revised seasonal forecasts have already been issued in response to this year's strengthening El Niño signal, and it's worth checking the latest update from a source like NOAA's Climate Prediction Center, rather than relying on outlooks issued earlier in the spring before the Super El Niño trend became clear. For anyone in wildfire-prone regions of the Pacific Northwest or Western Canada, the historical tendency toward warmer and drier conditions during Super El Niño summers is worth taking seriously well before peak fire season arrives. Reviewing your local fire risk resources and defensible space preparations earlier in the season, rather than waiting for late summer red flag warnings, aligns directly with how this year's pattern appears to be developing ahead of its usual timeline. Local fire authorities in these regions often update their seasonal outlooks based on exactly this kind of large-scale climate signal, so checking for any recently revised risk assessments is a reasonable next step if you live in one of these areas. Here's the honest summary of what this comparison reveals. The physical mechanism behind this year's El Niño is identical to every past event, driven by the same Kelvin wave and the same ocean-atmosphere coupling process that has always produced a strengthened subtropical jet stream. And what sets this year apart is the timing and the magnitude, with a textbook winter signature, already visible in July and ocean heat levels not seen since the 1870s. That combination is exactly why forecasters are treating this event with a level of attention usually reserved for winter outlooks, months earlier than that attention would typically arrive. Whether that early signal ultimately means a longer, more impactful event, or simply an earlier arrival of the same seasonal pattern remains the open question forecasters are watching most closely right now. If clear comparisons like this help you actually understand what's unfolding instead of just reacting to another headline about a record ocean temperature, subscribe so you don't miss the next update, because this event is still developing and the picture is likely to keep sharpening through the rest of the summer. Stay informed, stay prepared, and I'll be back the moment there's real movement in this forecast.